Good afternoon, ladies and gentlemen. My name is Vladimir Lushnikov, alias Vlad Sharp, and I'm here today to speak about the programming language D, library libd, and the Slate project, and how we can improve upon the current state of systems that we have. I'll briefly introduce what I'll be talking about today, explain what libd is and what Slate is, as I'm sure I haven't explained clearly enough already. Go over the problems with current systems and present the architecture of libd and Slate and ask for your participation. So the way our team sees it is that there are problems with design and implementation of current systems, Linux, Mac, Windows, obviously, and much of these come from backward compatibility options that the designers chose to kind of keep, and the code is stagnated a little bit from there on. In comparison to C, the D programming language aims to address some safety issues and convenience issues. For example, it's garbage collected. You don't need manual pointers. You have references like in any normal language, but you can use pointers if you so wish. So what we thought it would be nice to start from at the beginning and build a system which is independent of existing systems. And that's why libd was created by Madeleine Freudenberg, who's unfortunately not here with us today, and is one of the motivations for the Slate project. libd is a library written in D. It's modern, it's fully featured, and I'll describe that later. And we feel that design and architecture of systems is very important, and without proper design, you can't have a good working system. That's not to say you must design it from the start, but you must think about where what each feature you add, where is it leading to. So I'll introduce D. It's a high-level systems programming language. It is a systems programming language. It's if you go by benchmarks, it's about sometimes as fast as C, sometimes maybe twice as slow as C, based on like garbage collection and that kind of thing. It was implemented and created by Walter Bright, and he was, some of you might know, he was the first person to write a C++ compiler for Zortek, and so he's got more than a decade of experience, and he saw some C++ features that were not so clean, and hopefully improved them in D. It's an imperative language. You have object orientation. You don't need object orientation. You have template meta programming and compile time function execution, and I'll explain. The official digital mask compiler is not open source because the backend is proprietary, shared with the C compiler. So, but the GDC compiler is. So libd is a high-level runtime library for D. It's written completely from scratch. It was started a couple of years ago. It's not dependent on libc at all, unlike many libraries for other programming languages like Mono project or whatever. It runs directly on the various Unix kernels at the moment. I mean, there's no reason why it can't run on something like React OS or even Mac if you wanted it to. It's public domain, no restrictions on usage, no arguing about the GPL. The goals of the Slate project, we wanted to create something that is can be extended and used for a long number of years. So, and we wanted to improve upon the security and usability of current systems. I mean, things like UAC and Windows Vista, they don't go very far in terms of security analysis, but they are very annoying. We don't see that. We don't see any reason why there shouldn't be an environment that is both beneficial for us programmers and us users. In reality, such efforts to change things are often kind of directed into patches for existing systems. And while that does improve the code base, of course, it doesn't introduce radical change, which sometimes is very much needed. So the Slate project is an attempt to create an operating system, and I make that in brackets because we use existing kernels, and so we don't need to write all the driver code, etc., which many projects have started and failed to do simply because of the lack of manpower. We want it to be usable, and we want to write it properly, so it's perhaps not a project meant straight away for real-world consumption. It needs to, obviously, a couple of years to mature. We don't want to build on top of POSIX and other Unix applications. We just take the kernels, and libd provides a consistent systems interface for Slate, and we believe all this is possible. Obviously, to do more complex things, you need the right tools. Generally, you need more abstractions, and I'll talk about those later. And the prominence of Web 2.0-esque technologies, by which I mean the kind of drive to semantic content rather than just files on a hard disk you organize yourself. So Slate is meant to be a featured project. It's meant to be usable, it's meant to be secure, and last but not least, it's meant to be fast because, as I said, D is quite fast in comparison to other comparable programming languages like C# or Java. I want to go into problems of implementation at the moment, and while the Linux kernel is an amazing piece of software, it is hugely complex to anyone who's read its source code, who hasn't been a kernel hacker for years and read its source code. It's hard to read sometimes. You don't quite understand why you have to have 20,000 macros in one file. It's very much an evolution project. When Linux started in '93, and it was quite small, and now look what we've got. However, I sometimes personally wonder how you could actually run things on this Linux kernel, because there are more than 12,000 contributors, and it is an amazingly huge and an amazingly useful piece of software. However, there are problems. I mean, there is no mainline way to do network AIO. For those of us that don't know what it is, it's synchronous input-output. It's the sockets interface that never made it into mainline, and they've tried to kind of revolutionize the way socket files, and not just sockets is based, but so far no success in that. And it has no security infrastructure, and I'll talk about that later. Implements POSIX, and which brings me to some of the what we feel are design shortcomings of POSIX, mainly because POSIX was created a decade or so ago, and the requirements for functionality and system usability and security have changed. You can argue that it's too primitive. I won't say that you can do everything with POSIX. You can do, and if you look at what kind of technologies we have in Linux systems today, for example, then it's absolutely amazing. I'm not trying to take away from that. However, it's my first kind of issues with the security front, because you have all this API available to you. You can't really restrict without special kernel patches. Restrict security in a program, and therefore you can't use tools that automatically check whether the program is correct, or at least it doesn't do some willful damage to write some memory somewhere, make it executable, and you have a virus or a Trojan, or and too many side effects generally. The shared memory model, which I'll talk about later, and you can't. And most of the permissions have to be resolved at runtime, and there are. While they do exist, there is no way for you to say that and this application needs to have a certain capability, like a web browser needs to access the internet. It doesn't need to, say, interact with a camera that's attached to your computer. Another problem with POSIX is threading. Threading code in C and C++ is notoriously difficult to write. While POSIX supports message passing concurrency, which is perhaps easier conceptually and maybe slower, but easier to debug because you can isolate components, etc. While it exists in the POSIX standard, it's not widely used. And you have to be very, very careful with it because it can be tricky. So while multi-threading code is difficult to write, keep in mind that there are other ways to do threading than explicit shared memory models. And for example, if you take a simple client-server application, how would you write such an application? You would use the file operators because everything in Unix is a file. You would use poll, epoll, k-event, or whatever, depending on which system you're at. Or you could use an existing framework. There exists plenty of either open source or commercial C++ or C socket libraries. However, if you didn't have that option, and you weren't allowed to use such a library, then what would you do? You'd have to write everything manually, and because this is being done, I mean, there are quite many such projects. We feel that why not just abstract it away from program and make it part of a standard system library. Another problem which I find mainly with programming languages is that the current kind of state of imperative programming languages, you don't feel like you're writing multi-threaded code. You feel like you're writing sequential code, and you have these awful lock or synchronize statements all over your code. And perhaps we could find a better style to write programs in. Most of you are here because you are extremely interested in technology and hacking, and as am I. But there is a global shortage of good programmers, as most of us realize, and this is because existing, say, C programs are notoriously difficult to get exactly right because of side effects, threading issues, security issues, memory checking, etc. And the standard libraries are quite primitive, and let's not talk about .NET here. And some programmers can't even cope with a low-level detail anymore, and why should they? You don't need quite a lot of low-level detail. While POSIX is a low-level standard, you shouldn't need another 20 libraries to utilize it. And this is the background to the creation of libd and the motivations for Slate. And again, I will say that POSIX is absolutely amazing. It's great to have a standardized interface, and I mean, even Windows is starting to implement most parts of it. However, there are some issues, and we need to realize those, and we need to kind of see whether we can do better. Now I'll get into the real stuff of architecture of libd. Libd was written from scratch. As I said, it's completely independent. It uses the syscalls interface, and it tries to use as much functionality as is possible. It currently runs on OpenSolaris and Linux. It can be obviously ported to run on any operating system as long as it has, it's got it's public domain, and it's not backward incompatible with anything because there is nothing to be backward incompatible with. The key features of libd is message passing, Objective-C style, and this leads obviously to quite easy creation of distributed applications. It's got object persistence, again, distributed applications, and task-oriented infrastructure. So you don't create threads, you run tasks, which perhaps, from a human point of view, is kind of more logical. What I call green threads, what is called green threads is, for example, you can have as many tasks as you want, but if you just want to balance them over your two processes, you can do that. It supports different programming models, semi-procedural and fully object-oriented applications. It's event-driven mostly. If you know libevent or C#'s kind of delegates, then that's kind of the closest. And it's, for example, network input-output is much easier to do because you don't need to distinguish between asynchronous input-output or synchronous input-output. You just put the option there, and there it is. It's got stack borrowing, so if you want to make stack threads, then you can. And no main functions, because it was felt that if you have a task, then you can just have a program class and no public synchronized void main, like in some languages. It's already got multi-language support, and I mean locale settings and languages and character sets. It has a virtual input-output model, so some protocols that come with it, HTTP, FTP, standard kind of thing. It's got a library for command line options, so that all the options are standardized, like perhaps a bit like getopt in terms of making everything standardized, but in reality quite a far away. Better, I would say. It uses the concept of bundles, like OpenStep or Mac OS X IDSA. It's got an exception hierarchy. D is a language with exceptions and with comparable speed to C++, and a consistent command line interface for all libd programs inspired by VMS. libd is generally very pluggable. You can write plugins for nearly every subsystem. You can have your own user-defined message passing rules over Ethernet or over whatever kind of thing you want. Object serializers for remoting or whatever acronym you want to use for that. Plugins for virtual input-output and automatic plugin loading. And which brings me to the design of the Slate project. If it isn't clear to you by now, libd is nearly 100% done in terms of being alpha. It's not released publicly yet. It's still being tested. We feel that we don't need to, if we can test for some bugs, then perhaps we don't need to release quite so soon, and it will be released at least at most a month after this. And Slate is just an idea at the moment, which we are in the process of implementing. So I'll describe Slate. It's based on libd, and no C code, just D applications. Implementing it would require removing some of Slate's subsystems and adding them at high levels of abstraction. We think that we could go further with Slate than libd has gone. And thank very much Madeleine Freudenberg for implementing libd and making at least this possible. The core of Slate consists of libd, the virtual runtime system, the virtual private network layer, the hardware abstraction layer, transaction manager, and CMs. And here's a nice diagram of how we envision Slate to look like. So you will have your kernel interface, syscalls, which libd will mostly talk to, but the virtual runtime system can talk to as well. The virtual private network, we believe, is a core part of any computer, because most of them are networked and you need to have encryption between points. There's no point in having, hardware abstraction, transaction, yes. Okay, so the virtual runtime system is a straightforward virtual machine. It will include tools for compiling and analyzing programs, such as the bytecode verification, which I've already touched upon. And it will have a set of very minimal class library mappings, not like the system namespace in .NET, hopefully. It's not particularly a new idea, we admit. It's the Singularity and SharpOS projects, for example, have got the .NET virtual machine to run on as its own, but these have been their own kernels, and they haven't gotten that far, except what Microsoft has, but they have quite a lot of resources compared to open source projects. I want to just say that I've talked about message passing concurrency a lot, and while I am a great supporter of message passing concurrency, it's for some tasks it's not ideally suited, especially if you're running things on your local machine, and there isn't any reason that you shouldn't be able to do software transactional memory or just plain shared memory if your program has enough privileges, because obviously you can't do them if you have a distributed system running. The virtual private network, need for clustering and network security, standard protocols, nothing new. HAL, the solid project of KDE, a great step forward, I think, and when KDE will be released finally next year, I think we can celebrate a little bit. And there is the kind of the HAL was proposed to be in the core part because there is really no reason why devices should be handled differently according to their manufacturer. I mean, most of them have kind of standard protocols along them. Perhaps not things like graphics cards, but the kernel can handle those. I mean, the standard interface then would be things like OpenGL or DirectX. The transaction manager, just another component. You need some part to allow transactions to run in CMs, and perhaps all of you are wondering what actually CMs is. And don't be scared by this slide. It's just a bit of concept implementation, relation management system, blah blah blah. If you look at, I mean, it's pretty obvious that we as human beings map concepts onto implementations of them in the real world. I mean, share is something you can sit on and not fall through. That's kind of a concept. And being kind of a person with a mathematical incline, the concept of, perhaps the easiest example is the concept of tuners. I mean, if you have a pair of shoes, that's an implementation of the concept of tuners, but perhaps not all of you see that all the time. So what is CMs is, the kind of background to CMs is that you should have templates for data which you store on your local system or distributedly, but a distributed system is just a collection of local systems. And you have some axioms because you're not able to define everything in terms of concepts. That was proven. And it's like having a semantic wiki. What it is in a concrete level is it is a basic relational database where you can or you cannot change the table structure. It's got extensions for extensions for your own data types, so like like PostgreSQL or Oracle. And the example is if you have like a PDF or a book or a Word document, then if you have like a picture of Prague and you've tagged it to say it's Prague, if you want to learn more about it and you have some literature on it on your hard disk or whatever, it'll, because it's already seen that and made the link, you can just query your CM's store and it'll tell you. There's nothing to be scared of. Another example is running web applications. I mean, in the financial sector, for example, you need to know quite a lot of news relating to the companies that you buy shares with, you sell shares. And while this kind of linking is nothing new in specific areas, usually such systems are built in an ad hoc manner, which is not helped at all by the operating system, and we feel that it would be useful to have them built in a non-ad hoc manner. So to overview kind of what I said, the virtual runtime system, you would have higher level languages than D running on it, so you could have like Ruby or Erlang or whatever you wanted, or new languages. And the VPN should be primary method of communication with other computers for security reasons. CMs being the storage mechanism, and we consider these all to be very low level, as maybe paradox as it sounds. Slate, yeah.
How does your project relate to Plan 9? Because
it doesn't. I mean, we haven't collaborated with Plan 9. Plan 9. Plan 9 uses some of the kind of concepts that we are doing here, but we're building on libd and the D programming language, and we believe that's the way forward. Sorry if that doesn't answer your question, kind of.
Can I have? Okay. Eric Raymond said about Plan 9 that Plan 9 is better than Unix. It doesn't use POSIX. It's has many similarities to your approach, but it didn't take off because Unix is just not bad enough at doing its stuff. So maybe you have many great ideas, but it won't be really useful. It's always a gamble when you take on such a project to kind of try to realize those ideas. I mean, and make them popular. I would say that we have a good chance of succeeding because we're at least a bit later on in the. Like, okay. Yeah. That we're using, I mean, things like CMs, etc. We think basically that we're making a bigger step than that Plan 9 has made, and I'm sure if you and that's the reason we'll succeed. Okay. Thank you. Okay, because Slate would be targeted mainly at servers in the first stages. We feel that clustering is obviously a very important application, and why not have it at the systems level? And libd already provides a message passing interface, object persistence, serializing over the network, nice network interface, and this would help us implement clustering, and obviously the message passing being the kind of method used for implementing it. Now we'll talk about security, a bit about class libraries and the file system built on CMs.
Security functions, we build, our basic premise for security is that most of the higher level code from the core upwards would be built upon the virtual runtime system, i.e. it would be compiled to bytecode and then stored under the control of the operating system you're running on, Slate, with hashes to verify the identity, etc. And so you would have a security verifier, and you would have a what I call a polar coordinator, which will kind of be a slightly separate system which checks permissions on a kind of user level. Bytecode is easier to do in terms of security. You don't have to kind of you don't have to run the code to find out what it does. You know your kind of class library entry points. You know which functions are being called. Hopefully the class libraries themselves are code reviewed so that they don't provide as many bugs as the programs written by programmers using Slate. And as I said, we can assign, we can know what the bytecode really does, and then we can compile it natively again and store it in a secure fashion. And for user interaction, this is where the polar coordinator comes in. Principle of least authority is a very nice concept for security. I mean, you only need to allow certain applications just a bit of everything that they need, and we can resolve certain things automatically based on signatures from trusted publishers, a bit like you have in Windows already, but obviously more advanced. The design here is based on a principle, so it's we haven't decided how to implement Polar quite yet. I mean, there are several ways to go about it. We could just intercept all library calls and do it that way, or do it statically through the bytecode verifier. The kind of class libraries the class libraries would be kind of done in the same .NET style, but hopefully with much less obfuscation and sometimes bloat, and coupled with some high-level languages running on the virtual runtime system, it would prove, we feel, to be a very attractive system for developing applications. This is, I'm sure all of you are aware, this is why Microsoft has succeeded. They have excellent tools for building Windows applications, and while Windows is not the best platform to develop for, the tools really help you quite a long way. The file system, then, it would be the same as being the storage mechanism. While things like Google Desktop or similar projects, Beagle, have kind of started to do metadata indexing of files, we feel that they're just add-ons to a system, and we could just incorporate it into the file system itself, and kind of distinguish between user-created content and application-created content, i.e. In most cases, I find that user-created content, you tend to organize it hierarchically. Like your music collection, for example, you might have, or you might not, if you're using ID3 tagging or whatever. You might have them in a hierarchy of folders based on kind of genre or artist or year, and it doesn't need to be that way. We just store it somewhere within a table in a relational database, and then view it, however, in whatever fashion we like. The file system is not a description of how data should be stored. I mean, it could be a relational database. It could be streamed over the network. We believe this approach is effective because most user data doesn't belong to a single category. and kind of going away from the Unix way of putting socket and file operations into one, we think that with this, this will provide a very good reason for separating file and socket operations, because files are now semantic things which have metadata like photos, place, location, time taken, which you already have in the JPEG. You just read that and cache it. Okay, I'll quickly go through the other parts of Slate. Query interface, because you already kind of have something like the proc interface, and that in a sense is a query interface. You could like see the processors, their thermal states, process numbers, whatever, and just standard SQL or whatever syntax you wanted to use for it. Things like environmental variables are quite a crude concept, because say you have in a Linux system, you have an environmental variable set globally which controls some security function, which it shouldn't, but it does, because no one has thought of this, and you overwrite it in your bash RC or whatever, and bam, you've changed the environmental variable. It might be just for your shell, however. This is kind of like, a bit like, for package management, we'll utilize the kind of libd's bundles concept. Of course, we will be able to control where they reside on the file system, the file system being your kind of database files and whatever it needs for indexing and etc. And we feel that there is absolutely no advantage except perhaps speed, but as we all know, speed is very much a multi-core game these days. For an application to be a set of files just in some program files directory or in USR, the bytecode verification and storage are more secure and possibly more easy to manage if the system crashes, the transaction manager being kind of the gateway for that. Of course, CMs would be a pluggable entity, much in the spirit of libd, and a standard configuration interface. I mean, Windows has a standard configuration interface. It's the registry. GNOME has a standard. KDE has a standard. Why shouldn't an operating system have a standard configuration interface? The future direction for Slate is, of course, a GUI, more research into design, and perhaps we'll implement it someday. We've already started doing that, however, and we need your help very much. Slate is under the zlib license. It's not public domain, like libd. However, that shouldn't pose any problems whatsoever to help with implementation. So I'll just quickly go over what I've said. We're probably going to be aiming for the server market with Slate, which is our security across the network, clustering and concurrent applications, easy application maintenance, and programmability, and fail-safe applications, much in the style of Erlang. This is all possible. A user programmer benefit by class libraries in a higher level language than C, which, while being extremely good, is sometimes quite a pain to work with. If you need to do something complicated, it's an orthogonal environment across different platforms because it runs on current kernels, and hopefully easier to code for than something like C++ and OpenMP. So yes, I've presented libd in the Slate project, which are uncluttered by previous baggage and hopefully provide a more attractive feature set than current systems. And again, I can't reiterate this enough. We need your participation if OS 2.0 Slate will become a reality by the next millennium or whatever. So thank you for listening, and I'll take any questions.
Hello. Excellent. I'm interested in the storage layer. You're talking about it being a database. Now, a relational database is something fairly complicated with an optimizer to run fast. An object database then adds things like lists and pointers and bags and sets. And what you're trying to do here is add inference, which I would expect is an even higher level. So, if you want to store what in the Microsoft world would be a 10 megabyte spreadsheet with thousands of cells, how would you represent that and how would you make it go fast? Because one of the design goals is fast.
Well, I mean, an Excel spreadsheet is, there are two ways of going about this, well, two obvious ways anyway. One is to actually store the .xls or whatever inside a cell in the database and then just access it, and that should be fairly fast. However, what if you wanted to modify it? We all know that modifying data is, in a relational database, is perhaps a bit slower than trying to access it. And so the other option is, of course, to have another kind of mini relational database representing your table. However, how do you access it? How do you access it now? You just access it and then write it, and you have a cache of disk slashes, and that's that. I'm not sure whether there would be any significant slowdown with our approach. I mean, you could always optimize things away as long as you kind of keep it in memory for long enough for you to do some useful work. Then it should be fine, because then you just be updating it. At least that's how I can see it. Any more?
You said that libd will be released in the near future?
Yes.
And on which kernels will it be able to run? So as it does...
it runs on Linux and OpenSolaris, but it shouldn't be difficult to port it to the BSD. And
okay, thanks.
Okay, yes. I have one question about the compatibility plan. Do you plan to make it compatible on a high level, like somehow port applications over, like OpenOffice, fix it to run on libd and slate? Do you think that that's possible, or it is
very possible
so
to implement a POSIX a libc emulation layer on top of libd, and it shouldn't be significantly slower than libd itself. However, our team directly won't be doing that, but of course you can take it and do it yourself.
It's possible. It's
yes.
Major problem.
It is a major effort to write a libc kind of layer on top of libd, because libc is a big kind of venture, but yes. There's no reason why not.
Right.
Plus, existing C code can, of course, run while Slate doesn't control it. It can just run alongside libd code. They just can't communicate via normal methods of linker loading, etc.
I have another question related to the D language itself. You said that the digital mass compiler is not open source?
The front end is open source under the artistic license, the back end isn't. The GDC compiler uses the front end of DMD, the digital mass compiler, and uses the GCC back end.
And you said that the GDC is not fully compatible with the...
There are some minor quirks here and there. Mainly mainly in some obscure kind of D features, which you don't usually encounter unless you're writing systems libraries.
So you would say that using GDC is no real problem?
There is no real problem in using GDC at all.
Okay, thanks.
Test, test. Hi, you told about the bytecode verification that there should be a central instance or something.
The bytecode verifier should be kind of separate from the system that interacts with the user.
Yeah, right. Could this somehow be used or abused for enforcing digital rights management or something like that, or am I misunderstanding there?
I'm sure a company could take it and abuse it for digital rights management. We have absolutely no intention of doing that, and perhaps now you mention it, we could design it to make it more difficult for abuse.
Who is behind the Slate project? Is there any bigger corporation who is interested in this project?
No, we
You've
started
mentioned
quite
Sun
recently.
Microsystems?
But I've mentioned a couple of systems that kind of are similar, I feel, in style. But there is no bigger corporation behind us. We're just a group of hackers enjoying programming better systems.
Hello. The reason why we like Unix is because it's free, it's flexible, and you can use whatever language you want. You can use, for example, RiserFS, XFS, ext3.
Yeah.
But if you use Slate, you are forced to use this kind of file system. You're forced to use the D language. You're forced to use certain system calls or certain libraries because of the security system. It takes a lot of the freedom away.
Yes, it does. And I agree that while we might not be providing more choice in terms of kind of different file systems, if we're on the topic of file systems, imagine if you had ZFS natively available to you on the Linux kernel, then at least I would not see any reason for not to use ZFS, because it is a better designed file system than, say, ext3, which is, yeah, I mean, maybe ext4. So we don't feel that it's taking away your freedoms enough to for you not to consider using it. But you should be able to remove the CMs kind of thing if you don't want like a local hard disk or whatever. You can design to plug it away and replace it if you want. No more questions? Yep.
Do you think with this porting stuff, I've just thought about this, and this is like stupid. You take a C kernel, a C programmed kernel for the operating system, then you put libd on it, then you put libd glibc adaptation layer between it, and then you can run your old applications.
No, you can run your old applications. It's just that if you want to interact with them using things like dynamic loading, it just won't work. But they can run side by side on a normal system or whatever. But you lose the benefit of security things and etc. Sorry, is that not?
No. What I meant is not that it's unnecessary to do an translation layer if the kernel is C, and can you just run concurrently libd and glibc?
The reason we're not we're not proposing writing our own kernel is because it is too difficult for a couple of hackers to do in the space of, say, 5 years or whatever. So if we had the manpower, then we would propose our own kernel design. But that is out of the question because of the extreme complexity of writing a kernel.
So what do you think would it mean for the security if libd and glibc applications live in the same space?
Well,
And,
it
I
would
mean,
be
if
just
you
as
allow
secure.
that,
It would be just be as secure as your standard C application. There wouldn't be any improvement, I wouldn't say, because they can access memory, and that's enough.
All right.
Okay, thank you.